In this video, we are going to be looking at the start of trigonometry. We meet trigonometry 3 times in higher mathematics in our school. So this is trigonometry A, and we're going to start off by looking at radian measure. Now, you might have heard of radian measure before on your calculator, where you have, like we've always told you in the past, when you're working with trigonometry, to make sure that there's a small d on your screen, and sometimes that can be an R or a G, and the R is actually radian measure, so that's where you might have seen this before, but you wouldn't have known at the time what it was. So radian measure, like I said, we've always measured angles in degrees before. We've used a protractor to do that lower down the school, and we've always used degrees when we've been looking at trigonometry before. But we can now use radians as well. So radians are just another unit of measure for angles. So if we look at this, now 1 radian is the angle made at the centre of a circle by an arc which has length equal to the radius of the circle. So that probably at this stage is slightly confusing in words, so I'll just show you this wee video. So you can see there that we've got the red line starting us off, and that red line forms our circle. You can see the red line was our radius. Now if we take the radius out of the circle and put it onto the circle, that same length, that is 1 radian. Then have 2 radians, 3 radians, and on that straight line we actually have approximately 3.14 radians, so that's pi radians, make up that 180 degree angle. And obviously then it follows on that 360 degrees, that full revolution all the way around the circle, gives us 2 pi radians. Okay, so we'll just watch that again. So that's our radius there, it forms the circumference of the circle. If we take the radius out of the circle and place the same length onto the circumference, making that arc, and that gives us 1 radian. And the straight line then gives us approximately 3.14 radians, which is pi radians. And then obviously the full circle, it follows on that gives us 2 pi radians. So since a radian is defined by the arc of a circle, we can think of radians as the distance travelled on a unit circle. Okay, so the distance around the outside. So 1 radian is the distance travelled divided by the radius. Okay. So I suppose we need to be able to use this, we need to be able to convert between radians and degrees, we need to be able to answer questions in radians as well as degrees. So let's maybe look how we can convert these. So we know from the video that 180 degrees is pi radians. So that was using this diagram here, and you can see that approximately 3.14 radians was a straight line. So that's 180 degrees. It follows on then that twice that's 360 degrees, is 2 pi radians. Now we can get lots of other values from that. So the first one we'll look at is 30 degrees. Now 30 degrees is 180 divided by 6. So if we relate that to the radians, we know that 180 degrees was pi, so that means that 30 degrees must be pi over 6 radians. If we now look at 60 degrees, we know that 60 degrees is a third of 180 degrees, so 180 divided by 3. So again, if 180 is pi radians, then 60 degrees must be pi over 3 radians. Now look at 45 degrees, that is 180 divided by 4. So 45 degrees is pi over 4 radians. So always remembering throughout this is your pi radians is 180 degrees. We'll then have a look at 90 degrees, and that is 180 divided by 2. So that means that 90 degrees expressed in radians is pi over 2, or a half pi. Now, the ones that we've done so far are really important. They are the ones that you will use the most in higher. You'll use lots of others as well, but these are the ones that are really, really important because these will lead us on to exact values, and that will happen over the next few lessons. So it would be worth pausing the video at this point and taking a copy of those 6 at the moment. Okay folks, so hopefully you got a copy of that. We'll just move on, we'll have a look at 270 degrees. So 270 degrees I know is 3 90s, so 90 degrees multiplied by 3. So I know that 90 degrees is expressed as pi over 2, so 270 degrees then in radians must be 3 pi over 2. Because it's that 90 degrees multiplied by 3, so it's 3 multiplied by pi over 2. We'll now look at 225 degrees, and now just looking at all the values that I know, the most likely one that I'm going to use here is 45. So that is actually 45 degrees multiplied by 5. Now 45 degrees in radians is pi over 4. So 225 degrees must be 5 pi over 4. Might be worth pausing again and just taking a copy of the 2 bottom ones there as well for your notes. Now, sticking with the fact that pi radians is equal to 180 degrees, what if I just wanted to know what 1 degree was? Well, I'm sure you've all realised where this is going now, hopefully. So 1 degree is 180 degrees divided by 180. That means that 1 degree in radians is pi over 180. Now, that then allows us to work out any angle that we have in degrees in radians. So we can easily then convert between degrees and radians. So if we just have a wee look at an example then. So example 1, we want to convert 61 degrees to radians. Well, if we know that 1 degree is pi over 180, then we need to multiply that by 61 to get 61 degrees. So 61 degrees in radians is 61 pi over 180. We'll have a look at a second example now, and this time we're converting 65 degrees to radians. So again, starting off with the fact that we know that 1 degree is pi over 180, so 65 degrees must be 65 pi over 180. Now, you might notice this time that this one simplifies. That's 65 over 180. So that will simplify dividing both numerator and denominator by 5. And that gets us 13 pi over 36. So that's 65 degrees in radians is 13 pi over 36. So again, folks, just now would be a good time to pause the video and take these down in your notes jotter. Okay, welcome back folks. So we know how to convert from degrees to radians, so we now need to go the other way. So what if we want to convert 7 pi over 4 radians back into degrees? So I'm recognising here that pi over 4 is 45 degrees, and you can see that pi over 4 occurring within the 7 pi over 4, obviously. So actually multiplying that 45 by 7 gives us 315 degrees. Now, you could also do this if you know that pi radians is 180 degrees. You could do 7 multiplied by 180 and then divide it by 4. And it will still give you 315. But possibly what is slightly nicer is just if you know the conversions that I put up in red earlier for, so it was 180 degrees, 360, 30, 45, 60 and 90, if you know those really well, like I've highlighted here, that then makes this calculation much easier and you're not having to do 7 multiplied by 180 and divide it by 4. So try your best to stick to this method. Obviously if you need to use the other method, that's fine as well. Now let's have a look at example 4. So this time we're converting 5 pi over 6 to degrees. So again, I'm seeing this pi over 6 in here. And that's one of the ones that we know from earlier. Pi over 6 is the same as 30 degrees. We've got 5 pi over 6. So it's 5 multiplied by 30, which gives us 150 degrees. And likewise, like I said with example 3, what you could do is 5 multiplied by 180 divided by 6. But again, if you know these common ones quite well, then it saves you a wee bit of work in there. So just now again would be a good time to pause the video and make sure you've got examples 3 and 4 down in your notes jotter. Okay folks, welcome back. So the last thing I just want to do here today is just counting in increments of the different radian measure that we've learned today. So we'll start off by counting up in degrees. So this might seem as though you're back in primary school and you're chanting your times tables. This is quite good for being able to learn how the fractions work essentially within the radian measure. So if we start in degrees, we've got 0, 45, 90. Should start saying it along with me now as you go. So 0, 45, 90, 135, 180, 225, 270, 315, 360. Now that probably seems okay at the moment. It's like your multiples of 45. Let's try it now in radians. So we're starting with 0 as always, and I forgot to say this earlier. Obviously when we're writing an angle in degrees, we need our degrees symbol. When we're writing in radians, we don't need that. So make sure you're not putting a degree symbol on your radians ever. So we've got 0, pi over 4, 2 pi over 4, but we can see that that simplifies to pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which simplifies to 2 pi. And remember, obviously you've got your pi here and your 2 pi there, so that's going round to what would have been 180 degrees, and then right round to what would have been 360 degrees as well. Okay, so that's 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Now, let's count in increments of pi over 3 this time, which is 60 degrees. Okay, so we'll go in degrees first. So 60 times table, say it along with me, 0, 60, 120, 180, 240, 300, 360. Now, radians this time, so we've got 0, pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is 2 pi. That one's probably a wee bit easier because not as much seems to simplify on the way around there. So we've got 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, 2 pi. Now, obviously we're about to count in increments of pi over 6, which is 30 degrees. So you'll realise that obviously every second answer here is going to be what was in the 60 times table, if you like, or the pi over 3 times table. So you'll realise there'll be a wee bit of repeat here, repetition rather. So the degrees, we've got 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. And in radians, so 0, pi over 6, 2 pi over 6, which simplifies to pi over 3, 3 pi over 6, which simplifies to pi over 2, 4 pi over 6, which simplifies to 2 pi over 3, 5 pi over 6, 6 pi over 6, or pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, which is 5 pi over 3, and 11 pi over 6, and finally 2 pi, which is 12 pi over 6. So you can see all of those ones that have simplified, we've actually seen them in other ones, the other counting in increments of pi over 4, we saw the pi over 2 and 3 pi over 2 occurring, and when we counted in increments of pi over 3, we saw this one, this one, this one, and this one. They all occurred already as well. So that's just a wee exercise for you to get to know the radians a bit better. Okay, so if you go now and you can try the assigned exercise for today.